Hello guys! Today I'm here to present to you the result of statistical data analysis of the survey data you have provided me. But first, I would like to thank you all for participating in the survey you received a few months ago. That survey about your food and class choices was the base for this presentation. So once again, thank you. For simplification, I've selected 23 out of 51 slides that I feel are the most important. Well, what was the point of this survey? It was to answer these three questions. 1. How accurate are we at predicting our peers' food and class choices? When I say accurate, that means statistically significant at a confidence interval probability. 2. If you like a certain food, can we predict what class was your favorite? And 3. How did the answers to these questions differ after 3 months? Let me show you the short answers for those questions. Afterwards, I will explain in more detail how I obtained these answers. For number 1, we're not great at it. For number 2, you'll probably have English as your favorite core class if you like pizza. Well, but if you liked burgers, you are most likely to have social studies as your favorite class. For number 3, social studies skyrocketed in popularity from September to December. The approaches for this survey analysis were 1. Use chi-square to figure out how accurate you were at predicting others' food choices, and 2. Use Bayesian statistics and reverse conditional probability of favorite food to determine the probability of favorite core class. Keep in mind that this is meant to be a quick introduction to these important concepts that might help you in the future. These are the steps I took to answer the 3 questions mentioned earlier. To start analysis, I need to obtain my data. But first, I need to calculate how much data I will need. In this case, it means step 1 is that I need to define the sample and population for this survey. Step 2 is to collect data, which I did through Google Forms. Next, in step 3, I would organize the data. In the following step, I would perform chi-square and Bayesian methods on the data to find the answers to these questions. In step 5, I would repeat the September survey in December. Furthermore, I would need to see how this data changed over time from September to December, aka comparing. The final step would be to draw conclusions about this project. Well, it's time for part 1 of this presentation, the September survey. This survey had exactly 69 participants. Nice. It was released to you during your math classes, and the responses were all received within 1 day after its release. The questions within the survey will be listed 2 slides later. And here's where it began. For our LC6 size of 80 people with a 95% confidence level and a 5% margin of error, we would need 66 people to ask. However, since 69 of you responded instead of 66, this reduced my margin of error to 4%, meaning that this survey is even more accurate. How does this relate to you guys? It just proves that the next few results will be accurate to how you guys actually did at predicting your peers' choices. For a refresher, these were the questions on the survey. The survey was divided into 2 parts, one about yourself and one about your predictions about what others would choose. The part about yourself will be used as a population data to compare to. One of the questions was, what is your favorite core class? The next 3 asked what flavors you like when you ate pizza, burgers, and chicken. The last one asked you which of the 3 mentioned foods you liked the most. Part 2 had exactly the same questions, but this time you guys needed to predict what your peers had selected in their own surveys. This slide contains the full raw data of the survey. You can see that the totals add up to 69. It is divided into the actual data and the predicted data, just like in the survey itself. In red, it shows the raw number of people that selected each core class as their favorite. In black, you can see the distribution of salty, sweet, and spicy flavors of the 3 foods within those classes. Finally, in blue, it shows the raw number of people that picked each of the 3 foods as their favorite. This slide may look similar to the last one in format, but it actually changes the raw data to probability. Horizontally, the probabilities add up to 100%, differently depending on the purpose. For example, in the actual section of the data, you can add up the salty pizza probabilities of 13, 36, 17, and 34% to get a total of 100%. That means if you like salty pizzas, there's a 13% chance you selected math as your favorite core class. This is a hint for reverse conditional probabilities, which I will explain later. This is where we get into the statistical stuff. One of the main methods I will use is something called the chi-square method. The chi-square method is a way to know if the actual and observed data have a difference that is statistically significant. For example, in our case, we are trying to find how good we are at predicting our peers' choices, and the chi-square is a good fit for that. And that is good wording because there are 2 types of chi-square test: goodness of fit and test of independence. The goodness of fit is a very simple test, which does not apply in our case. The test of independence tests 2 sets of variables to see if they are based on each other or not. In our case, telling us if we are good at predicting or not. Well, how does the chi-square test work? You can see the equation in the top there. The Greek symbol sigma, which looks like a big distorted E, only means addition of all terms, and the term on the right is special. It defines our observed data, subtracting our actual, squaring that, and then dividing it by the actual again. You can see on the bottom one example. Since we're testing the chi-square for all English foods and flavors, we add up the values to get a whopping 26.51. To put this in perspective, the maximum allowed or critical value for this case is 9.488. This is actually the critical value based on the confidence interval probability of 90%. If we used a higher confidence interval of 95%, this value would be changed to 11. 26.51 exceeds 9.488, which means that the actual and observed data is significantly different. This means that our prediction is inaccurate. Now here we have the 5 tables for each class's food and flavor choices. I used the English one in the example in the last slide. The chi-square values can be seen as x squared. These values definitely do not meet the critical value of 9.488, meaning that they fail the chi-square test, also meaning that they are significantly different. This fail result establishes that these 2 sets of numbers for each class, observed and actual, are not very similar. One thing to note is that social studies almost met the criteria for passing the chi-square test. The total values for all 4 of the classes is also quite close to passing the chi-square test, but unfortunately it does not. What is Bayesian statistics? Well, it is one form of statistics other than frequentist. Frequentist statistics requires thousands, if not millions, of data points to accurately make a prediction. While using Bayesian statistics, it is possible to make predictions based on only a few. In Bayesian statistics, you can expand on your past prediction with more data to further refine your prediction. In the bottom right of the slide, you can see an image of Thomas Bayes, the father of Bayesian statistics. He is from England and only lived a short 59 years. On a side note, Bayesian statistics is a crucial part of the development of artificial intelligence and machine learning. Here I have a table from spreadsheets about the data from the survey. It is organized into classes, foods, and totals. In the red section, you can see the raw data. 11 people picked math as their favorite, 23 for English, and so on. Same for the foods. However, in the blue section, I put it into percentages. For the classes, I totaled it horizontally. For the foods, I totaled them vertically. This is the preparation for the Bayesian analysis. In the green section, I summed the foods and normalized them horizontally, which is the reverse conditional probability. Out of the 100% of pizza likers, 39% picked English as their favorite core class. And out of the 100% burger likers, 60% picked social studies as their favorite class. Just as a note, the red text on these few slides are the ones I believe are the most significant. These highlights were from the September survey last year. These are simply to introduce you the methods and techniques used to find the answers to our survey questions. The actual results of the survey will have changed since then, and they probably already have. Here are the highlights of this survey. Science was predicted to be the most liked class, but it wasn't in this survey. In my speculation, I think this is due to the fact that our opinions were still based on our last year's thoughts and experiences, due to this being at the near start of the school year. Next, the order of flavors was correctly predicted. I think this is quite amazing, as most of our predictions were inaccurate. Math is the only class which was predicted correctly, as 11 people predicted it to be people's favorite, and 11 people said it was their favorite. From all classes, predicted or actual, salty was the most popular flavor. In math, science, and English, pizza was the most popular food. If you selected pizza as your favorite food, you are most likely to have also selected English as your favorite core class. And if your favorite food is burgers, you are most likely to have social studies as your favorite class. Part 2 is a continuation of Part 1. A duplicate of the survey conducted in September was repeated in December, with the same number of respondents, 69. Once again, thank you. I did this survey twice because typical feedback surveys are usually done weekly, monthly, or even annually. The raw data format is similar to the September survey, so I will not explain it here. Once again, the probability data is laid out in the same format as in the September survey. Now, in the December prediction, the tides have turned. 4 out of the 5 different tables passed the chi-square test compared to the previous 0 out of 5. This means that they are significantly similar. This shows that our predictions have heavily improved in those 3 months, most likely due to the familiarization to the new peers, classes, and teachers. Part 3 is a bonus, brief visual comparison of the 2 surveys. Here we have 2 graphs. The left graph shows the change in actual, while the right graph shows the change in our predictions. We can observe that social studies increased in popularity in both actual and predicted, while math increased in popularity in actual, but went down in predicted. Once again, actual and predicted graphs are laid out the same as in the last slide, left for actual and right for predicted. Pizza decreased in popularity, while burger and chicken went up. For our predictions, chicken almost doubled in number of predictions from September to December. In summary, our predictions of our peers' class and food choices improved over time. Chi-square and Bayesian techniques are very useful in calculating our predictions statistically. Finally, if you like burgers, you like social studies, and that's a fact. Seriously, though, thank you, and good luck on your math learning journey.